around too?
Yes.
Because notice there's nothing
Yeah,
here. It just says,
yeah.
okay.
Okay.
So related to this question, are they just numerical or do you get like multiple choice type questions on your tests?
Multiple choice.
Okay, so one of the things you might notice here is as n increases,
Okay.
the standard error decreases. That's kind of a typical test question here that you might see. And similarly, if n were to go the other way, decrease, the standard error would increase.
Okay.
That's kind of that multiple choice thing you might see.
Okay.
Any questions on that before I move on to question 2?
No.
All right. All right, so let me snip in question 2 here. I can always, and just, I can always, like, if you're like, hey, I want another question, just like question 1, I'm happy to make one up for you. But for now, let's just go in order here. Yeah. Population has a mean of 200 and a standard deviation of 50. Suppose a random sample of 100 people is selected from the population. What is the probability that the sample mean will be within plus or minus 5 of the population mean? Okay. So one of the things that's really good is to actually be able to identify like what each of these numbers actually refers to. The first sentence is a little bit unclear. We'll just call it X bar for the moment. Although it's probably mu the way it's written. I don't know if that's unclear, the difference between mu and X bar.
Yeah.
But they're giving you the standard deviation sigma of 50 and telling you that n is 100. Okay. Is that okay from this first part?
Yeah, I get that.
Okay, so they're saying what is the probability that the sample mean will be within plus or minus 5 of the population mean? Now you've probably seen that z equals X bar minus mu over sigma divided by the square root of n. You've seen that maybe?
Yeah.
Okay, now what this is saying here is that the numerator becomes -5 in one case and +5 in the other. Like they're not giving you the X bar values, but if you need them, you can think of them as 195 and 205. Okay, now let's just say it was 195. 195 minus 200. Do you see how that becomes the -5 value?
Yeah.
Over 50 divided by the square root of 100. Okay, and this is kind of one way to do this problem. I'll show you another here in a moment. For the 5, and that gives you a z-score. So actually, we should calculate that real quick.
So if the mean's like 300, it would be like 295 to 300.
It would be so what I heard here, let me just make sure I understand. Like I'm giving you the X values because they're not given there, but you can determine them. But normally it would say like, what is the probability that the sample mean will be between, in this case, 195 and 205. Like normally they would give you that information. They're just being a little deceptive here with the way this is written.
Okay. So you just picked 195 and 205.
Yes, because it works out with the scenario here. So this ends up being a z value of -1. Okay, and then there's a second z value here, 205 minus 200 over 50 divided by the square root of 100. That equals +1. But I'm concerned here. Is it clear like why this is, or do you want more explanation on this?
Okay, so you don't usually use the numbers then? Like if you're doing 195 to 200, it doesn't, like you can use anyone. Like if you did 201, like if you did 295 and 300 in that same equation, then it would work out too.
It would, because the difference is still 5 and -5.
Okay,
which I think that's what you're asking. Yeah.
Okay, yeah.
Okay.
So then the answer would be 1 or -1.
Well, that's the intermediate result. So you've seen this normal curve probably in class a bunch here. Okay.
Yeah.
So here's -1 and here's +1. We're finding the area between.
Okay.
And this is where there's like a bunch of ways to do this. Okay. Using your calculator here. So I do not have a TI-83, but I've got our TI-84, but I've got a TI-83 I can pull up. Are you familiar with how to do this on your calculator or not?
No.
Would you are you guys allowed to use the full TI-83, 84 in the tests?
Yeah.
And they're like in person. It's not like we can't just go to a website to do this as
Well,
well.
it's in person.
Okay, all right. Just trying to figure out all the variables here. Do you have your TI 8384 available?
Yeah.
Okay, let me get mine up here. All right, so let me new share, get that going here. Okay, so I've got a virtual TI-83 that you should be seeing now. You want to turn it on and then go to second distribution. And do you see normal CDF there?
Second, where distribution at?
It's above vars. It's right there above vars. You can see that.
Oh, okay. Yes.
And then go down to normal CDF. So CDF is the area between two values. Now, when you hit enter, I believe
Okay.
you see something that's like upper, lower.
Yes, it's lower,
Okay.
upper, and then.
Okay, now I don't have that, but here's your lower value. Your lower value is -1. Your upper value is 1, and your mu is 0, and your standard deviation is 1. We'll talk about why that is in a moment, but
It's already in the calculator as 0 and 1.
oh, good. That's even better. Okay, so you just have to put in the lower and the upper values. Make sure you're using that negative symbol, not the subtraction operator. And whenever you're ready, hit enter, and you should get the same number that you see on my screen there.
Yes.
Okay, so that's option number 1 for how to do this.
Okay, I think I don't want to learn multiple options because then I get really confused.
Okay, I don't necessarily like this option though. So sorry, I should have maybe done the different way. Let me, yeah, I understand what you're saying, and I don't want to, I'm not going to be like.
I understand that one. How different is the other one?
So the reason the other one's better is you can give it the, no, I guess you can't.
I just want to keep it simple.
Okay, let's keep it simple. We'll go to normal CDF. So we'll go with that one for now. Is that okay?
Yeah, no, that's perfect.
Okay, so let me go back to the other screen. Let's see when that loads up. There it is. Okay. So that was under second distribution and then normal CDF.
Okay.
So that's this area between the two values. That is your answer here, 0.6827.
Okay.
Any questions on that? I mean, it looks like we're gonna be doing a lot more of that, but I just figured I'd start.
Yeah, it starts off like really basic, and then I think it gets more into like the problems on the actual exam. Like they just start trying to teach you how to get it in. I don't know the simpler ones, so that's why I kind of wanted to start with them.
Okay, so suppose that the population mean for income is $50,000. That's mu. Mu is 50,000. Okay.
Okay.
Notice the word population mean. That's why you know it's mu.
Okay.
The population standard deviation is 25,000. That's sigma, 25,000 like that. If we select a sample of 1,000 people, so that's n equals 1,000.
Okay.
Okay. What is the probability that the sample will have a mean that is less than 49,000? So that's essentially your X or X bar. Okay. So what we're trying to figure out is the probability that X, it's really X here is the right notation, like this. And that's where you need your Z value. Okay, so your Z is X minus mu over sigma divided by the square root of n. Okay, and that's where it's the 49,000 minus 50,000 over 25,000 divided by the square root of 1,000. Now, when you put this in your calculator, the numerator has parentheses and the denominator has parentheses. So if you don't mind calculating that for us, just to confirm.
Yeah, and I have a question. Did you use the 49,000 and the 50,000 because it was there? Like you use those two numbers in the problem?
You have to be able to differentiate between X and mu. So mu is for the population mean. That's why we have to use mu of 50. If you're thinking back to like what 0 and 1, is that maybe where that's coming from?
Yep.
So mu is 0 and sigma is 1 for Z. Okay. This information is for income. and everything gets normalized to Z. Like, let's say another problem is talking about grade point average or test score or, you know, whatever it is. Like when you normalize, it's always going to Z where mu is 0 and sigma is 1.
Okay.
If that's not clear, I'm happy to try to explain again as well.
No, that makes sense. Because it's the difference. I'm typing this in the calculator.
And go to 2 decimal places on this.
So -1.26.
Yes.
Okay.
So on your Z, 0 is right in the middle. That's what you were just asking.
Okay.
Okay. -1.26 is somewhere over here. I'm only drawing the picture because I want you to see the area and the curve. Okay.
Yeah.
All right. So now when we go to the same place we were doing this last time, second distribution, normal CDF. Okay. You have to fill in lower, upper, mu, and sigma. Okay. Now this time the lower isn't given. Okay. Now this goes out to minus infinity, but most students use is minus 10 to the 99. Okay. So if you don't know the value, you use minus 10 to the 99 for the lower. And if you don't know the upper, you use 10 to the 99. But in this problem, we know the upper. The upper is minus 1.26. Mu is still 0 and sigma is still 1.
Okay. Okay. And so then is the whole answer to the problem -1.26?
No, you have to go back to second distribution normal CDF to find the area under the curve.
Oh, so you use that same thing that we
Yes,
used last
yes,
problem?
yes.
Okay.
Yes, so give that a try. See if there's any questions on how to do that.
So if we don't know the lower, we use -10 to the 99.
That's right. We could talk about why, or we can just say, okay, I'm just going to use.
So, and it would be +10 to the 99 if we didn't have the upper. Okay.
That's right.
Okay. So it's 0.1038.
Yeah, sorry, I'm just a little behind. Yes, that's correct.
Okay.
Is that okay?
Yeah, no, that's perfect. I was just writing it down. Cool.
Let me know and I can move on to the next question. All right. Okay, suppose this is question 4. Suppose the population mean income is 50,000 while the population distribution is 25,000. We select a random sample of 1,000 people. It's probably that we'll have sample mean greater than 51,000. So notice this is really, really similar to the previous problem. It's actually like almost the same values. I think that's just to help you with the calculations, but the mu is 50,000. Sigma is 25,000. N is 1,000. But this time we want greater than 51,000. We want to find the probability that X is greater than 51.
So 51,000 minus 50,000?
Yes.
Okay. Oh, and it's 25 again. And it's 1,000 again. Okay, cool. So let's enter this in. Okay, I got 1.26.
Good. So again, I'm going to draw the curve. This time mu is 0, 1.26 is here. Since we want greater than, this means to the right. The previous problem is less than, that's why it's to the left.
Okay.
So again, you've got to figure out, well, what's my lower, what's my upper, what's mu, and what's sigma.
Okay, so then lower would be 1.26 and then upper would be just 10 to the 99.
You got it.
Okay. Okay, and then it's 0.1038. Oh, okay.
Perfect. I'm just writing it down because I know you're gonna look at
No,
that.
no, no,
I hope you look
good.
at the notes later, but yeah, please keep doing the calculations. There's some symmetries and things like that, but you don't need to know them.
Okay,
All right, new question here. Is that okay?
yes.
All right, here we go. All right, suppose we wanted to use a random sample to determine the mean GPA among students. If we know that the population standard deviation is 1.20, how large does our sample need to be to get a standard error of 0.01?
Okay, so they don't give us the mean.
And we don't need the mean, but so yeah, and that's, so you got to be really careful. Like, what are they actually asking for? They're asking for standard error,
Okay,
and that's the standard deviation divided by the square root of n. So probably in your note sheet, it says sigma standard error or something like that. I don't know. It'll say something like that. But that is the 0.01.
okay,
And they're telling you the standard deviation is 1.20. But they do not, you don't know n. In fact, that's what it's asking. It's asking for n here. What is n? Okay, so
okay.
you're solving for n. Now, if this were multiple choice, you might just try the answers, but since it's not, we have to do a little manipulation here. You're going to multiply both sides by the square root of n. Okay, so it becomes 0.01 square root of n equals 1.2. You're going to divide by 0.01. So square root of n equals 1.2 divided by 0.01. And then now you will square
How
both
did you get
sides.
0.01?
So that's given. That number was given in the problem.
Oh, okay.
That is the standard error. They're saying the standard error is 0.01. So in the first problem they did, they gave you sigma and n. This time they're giving you the standard error to find n.
Okay.
So 0.01 square root of n divide by 0.01. You could put this in the calculator. You can also wait until the final step because you're going to have to square both sides. So n equals 1.2 divided by 0.01 squared.
Okay. Okay, I'll put that. Okay, 14,400.
Yes.
Okay.
Good test taking strategy here is to always do the calculations twice just to see if they're the same. Make sure there's no errors on that front.
Okay.
All right, let's move on to
Oh, okay, that's the answer.
that's it. Yeah. So it was asking for the sample
Okay.
size.
Cool.
All right. Suppose that we wanted to use a random sample to determine the average income in the country. If we know the population standard deviation is 11,674, how large does our sample need to be to get a standard error of 37? Okay. So this is just like the previous problem. Sigma standard error equals sigma divided by the square root of n.
Okay.
They're giving you sigma.
Okay.
They want standard error to be 37.
What's the symbol for standard error n?
No, it's sigma, but they usually put a little subscript. That's why I was asking, maybe in your reference sheet. Sometimes it's like sigma e, sigma error. It depends on the class. Like every instructor has a little different notation they like to use.
Okay. I know I don't. She usually linked the sheet with the exam, and she didn't this time. So I don't know if you even have an exam sheet for this exam.
I'd be surprised if you've had one. You probably will get
Okay.
another one. Now maybe it's the same one as exam one. Like sometimes they just give you one for the whole course, and then you just got to go and find the right formulas, the new ones.
Maybe.
Do you want to try solving this one on your own here? It's just like the last problem, same steps, just different
Oh,
numbers.
so you just, okay, so you just do 11,674 divided 37 into the square. Right?
So just like the last problem, you want to undo, you want to get the square root of n out of the numerator, like we
Yeah.
did up here. So you're going to multiply both sides by,
Did I not say it right?
well, I heard I heard something different. That's one of the fun things about Zoom is sometimes I'm not sure. So that's why I asked. But yeah, just as long as you have this.
Parentheses, you have 11,674 and then divided by 37.
Yes,
And then you put that, correct?
yes, that's
Okay.
perfect.
It was like, wait.
It's not an oral math exam, so you know that's the good part here. It doesn't matter what you say, it matters what you know, what gets written.
That's true. So I got 99548.77.
Okay, so here it says to round to 4
Okay.
decimal places.
So okay.
So you got to go to that 5th decimal place and check it out, see if it's what you want. It's something. Yeah, so I've got, like you said, 99548.77720. So because that 5th decimal is between is 0 to 4, you just get rid of it.
Okay, so okay.
If it were 5 to 9, you would round up.
Okay. Perfect.
All right. Any questions on that before we move on to the next question?
Nope, that's perfect.
Great.
We're good.
All right, there we go. Slip that in. All right, the average clothes washer uses 15 gallons of water per load. Wow, that seems really high. With a standard deviation of 3 gallons, what is the probability that a random sample of 90 loads will provide the sample mean with within 1/2 gallon of the population mean? Okay.
Okay, so we're trying to find the mean.
So the mu here is what value?
We don't have the mu.
So this right here is the mu. I know it's
Wait, so what would okay, isn't population mean? Wouldn't that be the mean?
yeah, so this one isn't written exactly the same way, but we're supposed to assume that like the on average, like you go out and buy a washing machine, it's going to be 15 gallons.
Okay, so mu is 15 then.
Yes. And what about sigma in this problem? What is sigma?
Oh, would that be 3.0 then?
Yes. And how about n?
Okay, 90.
90. Okay. Now notice it says within 1/2 gallon of the population mean. So that's kind of like that first problem we did where it's plus or minus 0.5.
Okay.
Do you remember,
Okay.
us doing that
Yeah,
in the
so
first?
like 95 to 200.
Yeah, but this time it's the mu is 15. So
Okay, so
go ahead.
10 to 15.
That would be 5. We want 0.5.
Oh, so 10.95 to the
14.5. 14.5 minus
oh,
15.
to 15.
That
Okay.
and then the other one will be
So you,
15.
okay. Okay. I was just being
You,
dumb.
you take this value and you add it or subtract it to this number here.
Okay.
Is that okay?
Yeah.
And then it's still 3 divided by the square root of n. 3 divided by the square root of n. Okay. All right, now there's some symmetry here, meaning that whatever this answer is on the left, it'll be the positive on the right, or if you get the one on the right, it'll be the negative on the left. But it's always good to do the calculation, you know, again, just to make sure, like, did I do everything right? You know, is it perfect? I don't want to make any mistakes here. Will you go ahead and calculate each of those z values for us?
Yeah. I'm taking my notes too. I'm writing down.
Sure.
Okay.
And if I'm ever going too fast, like you've been doing, just say, hey, Matthew, you're going too fast, or I'm not caught up, or I'm not sure. Just this time is totally for you. So don't let me rush you at all during this process.
Okay, so I got negative 1.58.
Okay.
And then this is probably gonna be 1.58, right? If I did
Yes.
that, okay.
Yes.
Yeah, 1.58.
Good. Good. And the reason you do that is if you make an error in your Z, your next answer will be completely wrong. So it's worth checking here. On your Z here, mean is 0. Here's minus 1.58. Here's positive 1.58. Since it says within means between. So we want the area in between these two numbers.
Okay, do you do the normal CDF?
Yes, like we've been doing.
Okay.
Yes, good question. You need that lower, you need the upper, you need mu, and you need sigma. And you have all of those.
Okay, would the upper and lower both be negative? Okay, cool.
One's now the calculator will tell you, like if you've done something wrong, it'll sometimes give you an error. So just go back and make sure you've actually put the one that's in the right position. Lower and upper. If you switch them, it won't give you the right answer.
Okay, I did something wrong. Oh, so the lower, I can't do a negative sign? Oh, maybe I didn't put it in. Oh, I know.
Yeah, make sure it's the negative, not the subtraction operator.
Yep, that's what I did. Okay, so 0.8859.
Okay. Very good. Any questions on that?
Perfect, no. Nope.
All right, next question here. It says if the mean GPA among students is 3.25 with a standard deviation of 0.75, what is the probability that a random sample of 300 students will have a mean GPA greater than 3.30? Will you tell me the mu, sigma, and the n from this problem?
Okay, so 3.25 is the mu, and then 0.75 and 300. Is it usually in order most of
No.
the time? Okay.
I mean, like maybe in this class, like it's been very kind. There's not so kind.
The test that she gives, like these practice problems, is the really kind, and when you get to the exam, they're kind of way more complicated. So this is just like kind of learning it.
Yeah, so I would not expect that to be in order. You're
Okay.
looking for language like the mean, standard deviation, sample of. Okay, now this one is asking for greater than 3.30. So that's the probability that X is greater than 3.3 like that.
Okay.
So your Z is X minus mu over sigma divided by the square root of n.
Okay. Okay, so the same thing. Okay, that's what we've been doing.
Now, would you like to see another way to do this, or on the calculator? Do you really like the way? Okay.
Yeah, I'm fine with this.
All right.
Calculator. So you did 3.30. Okay, so then you did 3.3 and then 3.2.
Yeah, there could be a 0 there. It won't change anything, but that is.
So okay, I got 1.15.
Yeah, very good. So again, on your normal curve here, I like drawing it each time. We got 1.15 greater than means to the right. You're going to use your calculator there. Your lower.
So lower would be the 10 to the negative 99.
So that would be true if we were trying to find the area, left of it.
Okay.
Like we're going out to 10 to the 99 here. Maybe that is good to write.
Okay.
So the lower is 1.15, the upper is 10 to the 99.
Okay, why'd you put upper for 1099 then? I guess that's what I'm kind of confused about.
All right, the reason is because if you don't have a value in the calculator, this works almost every time. Okay, because you need an upper bound. The calculator like can't function with only one value. So it's like, how far to the right is this thing going? It's going out to infinity. Infinity is interpreted as 10 to the 99.
Okay. Okay. Does greater than kind of just give you the hint? So 10 to the 99?
Yes.
Okay.
And same with less than being 10 to the minus 99, or I'm sorry, minus 10 to the 99.
Okay, I have 0.1251.
Okay, sounds good.
Okay, cool. Done.
All right, let me grab the next question. Let's do 10 before we do 9, because 10's more in order of how to do these.
Okay.
All right, this one says calculate the z-score for sample of, this now answers your question. See how it's out of order? They're giving you n first. 19 observations and a mean of 63, where the population mean is 60 and the population standard deviation is 19. So in this problem, tell me mu, sigma, n, and x, please. Go ahead and read it again if you need to. This is really important though, be able to get the numbers out.
Ooh. Okay, so this 60 is n.
It's a population mean.
Yeah, the mean. Oh wait, isn't 60 the first one?
Yes.
Okay. And then the 63 is n.
So that's the mean of, that's x.
Okay. Okay, so then okay, is 19 and then 19? They're both 19, right?
Yeah, which, I mean, I guess that's kind of odd, but yes. Yes.
So standard deviation is that first one though, right? Before the n. Okay.
Sample means how many did you measure, and then
I did.
standard deviation of 19 is your
Okay,
sigma.
I don't know.
Okay, so this one's just asking for the z-score though. You don't have to do anything besides calculate z. Z equals x minus mu over
How
sigma.
did you know to calculate the z-score?
I'm just
Okay, just reading it.
just going, but yeah, based on usually the thing they want is at the end, but sometimes it's at the beginning.
Oh, okay. I guess I've never seen that. Okay.
So the order here is super important, because on your test, especially now that you mentioned it's multiple choice, like they're both the positive and negative will be there. And perhaps even the scrambling of like, if you get the wrong numbers.
You chose 63 because that was the mean.
Yeah, and more so because the population mean is 60. So I know that has to be mu. When it says population mean,
You always pick the population mean for doing that blank minus blank, right?
yes, the second one is always the population mean.
Okay. I guess I just need to learn that.
All right, so yeah, go ahead and calculate this.
Okay, hold on.
Let me know what you could come up with.
I know I'm behind. Hold on. So you really just, how did you know that it was 63 to 60?
Because it's the formula, some of it comes back to the formula. The formula has 4 things that you need. There's no extra information there. It is the way it's written though. It's saying for a sample of 19 observations it's really saying with a calculated X bar of 63. Like of those 19 observations, they measured that the mean is 63.
Okay, so I'm gonna ask, is it like you always do mean minus mock population mean? Like I'm trying to figure out how to do the numbers then. Okay.
It's your mean, meaning like the one you calculated minus the population mean. Yes.
Okay, that makes more sense. Okay, let's put this one. Okay, so 0.6882.
Sorry, yeah, let me see. Yes, 0 point. So usually 2 decimal places on these. Double check what your teacher wants.
Oh, it's just 0.69. Okay.
Yes. Usually it's 2 decimal places on Z-score.
Okay. Okay. So then you input that in, but where do you put 0.69? Would it be that lower, upper, and how do you know which is
No,
which?
that's the difference here. And every other problem, this is really important here, is you calculate a Z-score to then find the area. Like the Z-score, sorry, this is in the wrong place. This Z-score leads to calculating the area. This problem just asks for the Z-score. So you are done right there.
Okay. Okay. So you just have to look out for Z-score or further.
Yes.
Okay, cool.
So you're done. Like this is your answer, 0.69.
Okay.
All right, we're ready to move on to 9.
Yes.
All right, so 9 is kind of different than what we've been doing. All right, so it says if the mean GPA among students is 3.25 with a standard deviation of 0.75, and we select a random sample of 300 people, at what value for the sample mean would be less than exactly 95% of possible sample means? So look over these numbers and tell me what is mu, what is sigma, and what is n, please.
I already forgot which is which. So, but with the 95%, is that, no, not 90. Okay, wait, for 300 people though, it'd still be like 295 to 300.
No, this is don't worry about that for a moment. That's
Okay.
what makes this problem different. Okay. But
So for standard deviation, then the 0.75 would be the middle one. Okay.
okay, good.
And then, oh, wouldn't sample mean be the mu?
No, they're saying the mean GPA among students. They're saying like of all the students out there, the mean is
So
this.
3.25.
Yes.
Okay. And then n 300.
300. Yes. Okay. All right. Now this is where we're going to go back to this last
We're
part
trying
here.
to find the x, right?
Yes. So we're normally given X, but this time we are not. All right. And that's what
So
makes this good.
on 10, the 0.69, what was that for? What was
That's the Z value, the Z
with,
score.
what is the z-score
Okay.
symbol?
Good question. Good question. So on the normal curve here, Z is along here, along the bottom,
Okay.
and the areas are inside.
Okay.
Okay. Now for this problem, here's what we want that's a little bit different. We want the area to be 0.95. We want 0.95 to be the area in this part of the curve.
Okay.
So you can either go from the Z-score to the area or the area to the Z-score. So we need the Z that goes right there.
Okay.
Now to do that, let me see if it's under distribution again. Yes. Do you see inverse norm under distribution?
What do you mean?
Go to second, or you calculate second distribution. And then inverse norm,
Yes, number 3, okay.
number 3. So choose that and tell me what you see, because I don't think mine will.
The area, so you just put 0.95 because it already gives the other 0, 1.
Okay. And then I think it asks for left tail, right tail, or between.
No, it just asks for area.
Okay, and not one of the options further down.
No, it just says 0, 1 and paste.
Okay. So what
So
is
1.64.
okay, that sounds correct. Yep. So 1.64. So now that's really important. Your Z is 1.64 like that. Okay. Is that clear so far?
Yeah,
Okay.
okay.
Now we're further working backwards because we're going to use that Z equation.
Okay.
Z equals X minus mu over sigma divided by the square root of N. So now we have Z. We were given mu, we were given sigma, and we were given N. So X, like you said, we're going to solve for X in this equation. So on your reference sheet, it may already be solved for X, not sure. But X is
So this is like 10s formula as well.
okay. So we can do it with the numbers though. We can just put the numbers in here. 1.64 equals X minus, and then I need to grab the numbers again. 3.25. Sigma was 0.75 over the square root of 300, like this. Okay, sorry for all the scrolling.
Right.
So we're solving this equation right here for X.
Okay. Okay, back before solving this though, so I get that number 9, we're trying to find the X, but then for number 10, the Z score was 0.69, and that doesn't have a symbol, it's just Z.
It's just
Really?
C.
Okay,
Yes.
okay. I got lost there. Okay. So how do you put that in the calculator?
This right here in the red box,
Yeah.
you can't. You have to do it by hand.
Okay, so how do you do it by hand?
Well, let me actually. So there is another way. It's part of that inverse norm. So I can show you that. I don't know if it'll be clear, but
Okay.
would you like us to do it that way?
Yeah, let's do it.
Okay. So when you go back to inverse norm,
Okay.
do you see where it says mu and sigma?
Yeah.
You change your mu to.
Mhm.
Why is this freezing up on me? You change your mu to 3.25.
Okay.
And then your sigma is not 0.75, it's 0.75 divided by the square root of N. So in your calculator there, you're going to write 0.75 / square root 300.
Yeah. Okay, that makes sense.
And then it will generate the correct value that you were looking for.
Okay. And so you would do that instead of that equation you kind of showed?
Yes, they give you the same answer, but that's without, wanting to solve this.
Okay, then, okay, perfect. That's what 3, because I can do that on the test. Okay. Oh, shoot. Okay. So 3.32.
Yes, perfect.
Okay. Cool.
All right,
Okay.
so the lessons are 50 minutes, so we got a couple more minutes here. If there's something else you would like us to do or have any follow-up questions.
Yeah, I guess I got a understanding of beginning. So yeah, that's good. Cool.
All right.
I want to do another one. I'll book it. So